All right. Well, welcome everyone to AI, the cause of and solution to all of life's problems, presented by Jay Schultz. I am David Berg, a BI developer with SMPH, and I'll be moderating today's session. So after this presentation, we'll have some time at the end for some Q&A. So please feel free to place any questions that you have in the chat during the presentation, and we'll answer them at that time. Also, there should be a chance for you to ask your questions in person as well there at the end. So I'd like to introduce Jay Schultz. Jay is a system engineer with the Aquatic Sciences Center. He's worked at UW-Madison for the past 10 years and is a jack of all IT trades. Recently, his interests have involved the fast-changing world of AI. He and I were joking a little bit that it's changing so fast that he had to update this presentation multiple times while he was making it because of updates to the AI world. So without further ado, here's Jay.
Thanks, David. Appreciate the introduction there. Hopefully everybody can hear me okay. So we're going to get started here. Perfect. So we're going to talk about artificial intelligence, the cause of and solution to all of life's problems, to co-opt a Simpsons phrase that some of you may have heard before. So let's get started. What is AI? Well, AI is math. AI is a tool, maybe not that kind of tool. But basically, it's the overarching term used when we're describing several related technologies, such as machine learning, deep learning, which is a subset of machine learning. And then you've got biology-inspired algorithms and search algorithms. So you kind of went through those types. So AI, as you can see, is kind of the overarching container here for different types of AI. Machine learning uses advanced algorithms to detect patterns in large data sets. Deep learning is a subset of machine learning, which uses neural networks for in-depth data processing. And generative AI is the chat GPTs and our image generation, video generation AI models that can generate content from essentially inputs that we give it or nothing at all, depending on how we train it. You got machine learning, deep learning, Gen AI. So machine learning uses the advanced algorithms, detects patterns. It can be trained, supervised, semi-supervised, or unsupervised. So some of these common uses would be something like Netflix, Amazon Prime, and your Spotify recommendation lists. You can also use like drone automation, Starship robots, things like that. There's different machine learning paradigms, as we talked about. So supervised is where we give that model, the training model, labeled inputs and the desired output. So the goal is for that model to map future unlabeled inputs to the appropriate output. Unsupervised is when we give it unlabeled inputs and set it free. So we expect the AI to look for clusters and associations of data items. Just a little note here, I generated the two images in the center and the right using Gen AI. The one in the bottom middle column was actually the safest for work one I could use. And the prompt was setting AI free at work while the boss is away. So you can see what happens. And then semi-supervised is given labeled and unlabeled inputs. It starts out trained as a supervised model, it's given unlabeled data and set free. So the prompt for that bottom right image was, please draw an unsupervised toddler while mom's on the cell phone. And you can notice that Gen AI doesn't do text very well here, and we're going to kind of talk about why that is in just a little bit. So here with deep learning, to kind of go into the subset of machine learning here a little bit, uses what we call artificial neural networks, or ANNs, to translate inputs to outputs. Outputs are extremely accurate label, category, or representation of whatever data you're giving it. And it's essentially designed to mimic the function of the human brain. So when we're looking at Gen AI here, we're going to start looking at, oops, I guess that slide is a little out of place, my bad. So ANNs, they're inspired by the neurons in our brains. Connected nodes in a neural network are called neurons. Each neuron has mathematical functions that process inputs and then predict an output. Basically, the one thing I want you to take away from this is that there's at least 3 layers of neurons all linked together. You've got your input layer where you give it the data. You've got a hidden layer or layers where the data is actually weighed, processed using various algorithms and math. And then you have the output layer, which is hopefully your desired output or the output that AI came up with on its own. So here's kind of a simple representation of it with a one hidden layer neuron. So you can see here that this ANN has a very simple input-output structure. And you can kind of see here or kind of extrapolate that any inputs you give to this hidden layer are going to be only weighed a few times. So your outputs aren't going to be near what you want them to be if it hasn't been trained. So this is kind of like a model availability for like what's going to happen in the future as far as some people have predicted. So right now we're in the 2023, 2024, 2025 era. So we got really good text, so we can do, as people were saying, finish up a Excel macro or, write a scientific abstract or something. Code, like PowerShell, macros, all that stuff. It's very helpful. Images and video 3D gaming, we're still kind of in the pre-beta days of those. It's getting better. We've heard of some issues where people have impersonated other people using AI to cause damage or other things like that. So then we're going to get into the ethical and morality of that in a little bit. Here we can take a look at the types of Gen AI that are fairly popular. Again, you can kind of see the patterns and structure of input data. We've got Bard, which has now been renamed to Gemini, one of the many edits I've had to make. OpenAI, ChatGPT, DALL-E, Synthesia, can create videos based on a few prompts. Jasper and Copilot are just some of the ones that are out there. And of course, the fact is, Gen AI is just difficult. It's hard. A discriminatory model just needs to look for a few telltale patterns in data. It's not really concerned with the data space. This is this, this is that. It basically just evaluates everything as it comes in one-on-one. Generative models must create something from model. Generative models must create something from nothing. So they're very concerned with the data space. I must convince you that this is real. And then when you combine these two, you get what's called a generative adversarial network, or a GAN. So let's break this down a little bit. So we have a diagram here I stole from Google, which kind of really lays this out well. So you have the discriminator in the middle. That's basically your decision-making machine. You have real images up at the top left there, which is your input. And then you've got the generator down at the bottom, which is the AI model that is generating input. So what's going to happen is that discriminator needs to be able to determine or discriminate real data from generated data. So as you can see here, you've got, the AI trying to make a $10 bill at first, and then I guess they switched to 20s and the AI was more interested then. I don't know. So what we have to do is train this discriminator. So what we do is we basically tell the discriminator, the classifier, to use positive and negative weights during training to evaluate real and fake data. Here, we've got the generator, which is going to go incorporate feedback from the discriminator when it's being trained. Its goal is to generate fake data that is classified as real by the discriminator. So it's trying to generate fake whatever we give it as a real, and then have the discriminator be able to say, yeah, this is real, or no, it's not. So let's go through a quick example here. We've got a couple of pairs of boots and say we want to train this thing to generate footwear for us, or boots. In this case, we're going to stick with we'll go with boots just to make it a little easy. So as we start training this thing here, you'll notice that we get some random noise shapes. The discriminator is smart enough to say, hey, nope, you lose, generator. That's definitely not a boot. So here, gets a little closer. We got Italy and some more noise. Discriminator again, nope. And generator lost once more. However, the generator, after many iterations and a lot of trying, finally gets some footwear. You get a sandal in there. It's not quite a boot, but it's in the same realm. So discriminator says, huh, I really don't know what's going on here. And the discriminator loses, and we actually have a generated output. The reason the discriminator loses is because it cannot determine right now the difference between real image and a generated image. So the ultimate demise of Gen AI is convergence. You would think that this would be a good thing, but it can also be kind of problematic, as we'll see. So the generator gets really good at creating. So if we go back to the slide here, it's got, all the shoes, footwear created. The discriminator rewards it by giving it high weight and choosing it as the output. Eventually, though, the discriminator will start essentially flipping a coin since it can't tell real data from generated data anymore. So this can kind of lead to random feedback, quality collapses, and then this is also known as what is AI hallucination. AI models basically are a decision-making process. So we're talking a model, we're talking like the framework that an AI uses to analyze data and make judgments. So as we talked about before, it could be supervised, unsupervised. And then inference, you basically deploy the AI model into a use scenario that it's matched for. Foundation models are pre-trained on a broad set of data. The more data, the better. Limitations including cost, computer power, and data quality. And then we also have ethical challenges, and data quality can lead to undesirable behavior. So obviously training data has to be modeled or has to be monitored. So here's kind of a breakdown of the foundation model. You gather all your data at scale, say employee health records or anything that you might be wanting to analyze, say research data. You take that data, train it, evaluate the model's performance with that data, and then fine tune it as necessary. So as I used with that EHR example before, we've got a bunch of medical data that we can feed into this model, and then we can create different tasks for it. So we could say, given everybody with this condition or this term in their chart, can we find or group something similar and maybe find some similarities that could lead to a cause or some kind of inference there. And then multimodal models, these are models that learn from different types of data. So images, code, audio, etc. They respond with a greater variety of results, and most foundation models these days are multimodal. So they'll generate images, code, audio, etc. Going back to that slide where I had Gen AI create images, you notice that the text was all goofy. And the reason for that is these models are good, kind of really tuned for one thing. In this case, image generation. It was not tuned for language, but it still tried to extrapolate image from pixels, which was something we'll kind of show in a little bit. Large language models. These are statistical language models trained on massive troves of data. I forgot to update BART there. Shoot. Okay, so it's Gemini, not BART anymore. ChatGPT, and then anybody remember Eliza? Came out in the 60s. Simple chat program that would basically use questions to reply to given input in the role of a Rogerian psychotherapist. So LLMs, as we know, use prompts to generate content. I'm sure most of us have probably used an LLM at one point or another. The prompts, using prompts correctly can be an art form. You have to be very clear and specific. Treat it like a smart toddler, I'd like to say. Give it some context and role play. Say, you're the HR director, write me a policy on XYZ, something. And then the other things you want to do too is use references, give examples, give a length, and specify styles. Not that kind of styles, but do you want it in Old English? Do you want it in text speak? Do you want a really long response, or do you need something, just short and sweet? So now we're going to talk about diffusion models, which are models that use noise to split images. So you can see this image of a bird here that gets broken down basically pixel by pixel. Analyzes that pattern image and then reverses the process and spits out a new image based on features of the input. In this case, we've got a model that used cherry blossom near a lake snowing for stable diffusion, DALL-E 2, and Midjourney, 3 different diffusion models. And you can see they all came up with different interpretations. Parameters we're kind of going into the components of a model now. So when we're talking about parameter counts, we're talking about the value assigned between neurons and synapses in different hidden layers, going back to that ANN, the artificial neural network that we talked about before. And then bias is the numerical value assigned to the sensitivity of the input. So we can have something weigh a lot, but not be very sensitive, or we can have something weigh very little, but assign a lot of bias to that. Higher parameter count gets more of the complex and nuanced aspects of language, sometimes called the quality of representation. So if we give it a lot of parameters, it's going to learn, but it also takes up a lot of memory. And anybody who's ever tried to run an LLM on a local machine can tell you that it's an exercise in patience sometimes, especially if your machine's a little bit older. Basically, you want to use the parameters to focus on efficiency in tasks, not the number of parameters that you have. I like to compare it to like an airplane cockpit. We can have an LLM that's kind of designed more for our specific needs, just get us from point A to point B and fly. Or we can go in the Airbus A380, Chat GPT 4, 5, 6, whatever's coming down the road here. So you can kind of see that we use parameters that correspond to our needs. So here again is that artificial neural network. So you can see the weights here given to each of the neurons and synapses, and then the biases and weight values that get assigned. So as each input layer there gets a level or a number assigned to it, you'll look at that hidden layer, and you get the bias of 8, 8, 9, 9, but those get weighted down, and then you get the outputs about 4.8 and 0.51. Tokens are another component of models, and basically what these are is a fundamental unit of data that's algorithmically processed. So like a single word, part of a word, a punctuation mark is a token. Most words are a single token, some are not. Indivisible is an example of a word that is 2 tokens, which is funny thing, indivisible. It's like flammable, inflammable, what a country. Tokens map together which words and concepts appear in text, more context, better understanding of the relationship between words. So you can see here, I used a tokenizer from OpenAI to kind of show us how tokens are kind of broken down. And if you get a chance, I suggest just checking out that website. You can click on an example and it'll generate a token for you and kind of show you what it's doing. So now that we kind of know some of the inner workings of AI kind of at a high level, we can use this now to find data patterns that we might take forever to find. We can chat with customers and offer suggestions for items, and then we can extrapolate information from incomplete. AI is not the tool for everything, however. Like the cloud, the iPhone, Tamagotchi, 4K, HD TV, hoverboards, Google+, Google Wave, Google Glass, Google Bard. AI is a tool. Let's use the right tool for the right work. A lot of people just say, let's shoehorn AI into everything, but not exactly something you do. It's also important to remember that each category of AI has its own strengths and weakness. Artificial narrow intelligence is good at facial recognition. Artificial general intelligence and super intelligence do not exist yet, but these are starting to improve. And this is where we're starting to get into like the Skynets and self-aware bots. And then machine learning, good to great at generating content, but limited by training methods and data. So how can you actually use AI? Just pause there for a second because we're all a research institute and we know how this works. All right, so research data and analysis is probably the biggest one that we've used it for here at Sea Grant. We can pour through troves of data, say on like PFAS data, find patterns that we would see or that would take us a long time to find, and then we can limit our scope based on what we train it with. We can also deploy AI in risky situations, so we don't need to any longer sacrifice a grad student or intern on a rocky bluff to try and collect data. And we can do things like study erosion without affecting human safety. And we can do all sorts of different things. With the drone, we can capture images, and then with those images, use AI to study impacts over long terms of time that we might not collect with satellite data that could get clouded out, or you can create an AI presentation for you. I wish it did not. AI-based tools, though, can improve academic research. So you can use Scite, which is a research-trained AI. Tableau is available here at UW campus, and Mendeley is another reference management software. And then this was put in the icebreaker, and we had some really good examples. So we had people who used it for PowerShell, Excel macros. Some people haven't really tried it yet at all. Maybe just they haven't had a chance to, or it hasn't come up. So let's talk about some of the problems AI can solve and cause. How many of you remember Tay? You can just, silently smirk to yourself if you remember. There's a few other things here that I've done. I went to Amazon's AI tool and asked it to describe the advantages of a strong labor union, and it was more than happy to giving me that under the product info for a solid state drive. So you can see there are some obviously good things and some bad things. The chatbot that called itself useless is probably one of my favorite stories. But AI use has to face and address challenges head on. So bias and discrimination are really big factors. Lack of diversity. The data that we get and feed it is already discriminated and biased because we're human and we're the ones giving the model the data. So ethics, who's going to regulate AI? So if we have somebody who's impersonating a president or foreign leader on a video, how do we know that's the real person now? We're getting into that age where determining real from fake is going to be a little trickier. And then impartiality, reliability, security, accountability are some of the other factors we have to look at.
I'm not sure if you saw the screen down
privacy, facial recognition
tech. It's not showing the full picture.
I'm sorry, something wrong? Okay, I heard somebody in chat. Facial recognition technologies, privacy problem that I'm sure many of us have heard about. Stuff leaked onto the web, GDPR, other privacy regulations, copyright challenges, and then use of information without compensation. So bias and discrimination, we use it a lot for recruitment, healthcare, risk management, marketing, communications, and then you can think to yourself of some of the other processes that we've used AI for. Recruitment here is one of the areas that AI gets used, and we can see here, I've highlighted a section where it shows that bias results in discriminatory hiring practice, and this is based from limited raw data sets. So this isn't a model issue, this is the issue that the data itself is not good. And we have another example here, the healthcare, trying to predict healthcare costs rather than illness, but because access to care is different for underprivileged people, we could have some problems with data, again, not being clear. And again, another data issue with risk management. So we've got the data is inherently biased, and so things like credit scores are noisy indicators. It's not a good way to kind of manage and show relationships among different groups. So another problem too is with because you like X, you like Y generalization problem. A good thing about AI though in marketing communications is it does give you a little bit of a target audience, but it can also bias that target audience. And then you can also think of some other examples of AI and some discrimination that you may have thought of. So the question is, how do we fix this? Training data basically needs to be the ideal scenario, what should be and not reality, what is. We can't fix disparity and discrimination if we keep feeding AI models same flawed data. And the goal is that we have to create a utopian world in data, but obviously society exists in a biased world, so all data will always be biased. So kind of a killjoy there, but I mean, we can at least recognize what we're trying to do and maybe how to fix it. So some of the other things we could do, implement data governance and auditing, evaluate models by social groups. Some of the good things that AI can do for underprivileged people, it's really good at text-to-speech now for people with disabilities, visually impaired, captioning is a really good AI technology. It's not perfect, but I'd say about 99.5% of the time you can get the general meaning across. And then technology. Why not use software algorithms themselves to grab unbiased data and then set that as the data set for the model? So ethics, talking about governing AI, transparency, impartiality, accountability, reliability, security. I'm going to kind of go through this really quickly because it's a little dense, but there are some institutes across the world, GPAI, the United Nations UNICRI is focused on using AI to focus on crime, terrorism, and criminal behavior. AI for Safer Children initiative, and then there's a toolkit for responsible AI innovation in law enforcement. GDPR requires organizations using AI to obtain explicit consent before using personal data. And the IEEE Global Initiative on Ethics of Autonomous and Intelligent Systems has released several policies and guidelines that they want to use for for monitoring and ethically designing AI. And they have a framework called the Ethically Aligned Design that you can go check out. The ITU standards has created a global summit called AI for Good. It's online, you can attend it virtually for free, I believe. I didn't grab the dates for it, but I can double check that later. And then privacy. And we had this, maybe you've heard of this, where back in the day, Target started analyzing purchases and then started sending coupons to a person who was pregnant before she revealed her pregnancy. I kind of did a Snopes on this, and there's some varying degrees of maybe truth to this, so I'll just put that out there. But it is something that could happen. I mean, it's not out of the realm. Location, routine data, where's data stored? If it's free, just remember that your data is the payment. Reddit and Google now just have a $60 million annual deal for your data, making Reddit money. So we kind of went through GDPR, Consumer Privacy, California Consumer Privacy Act, copyright. One thing that I like to point out here is AI generated works by themselves cannot be copyrighted currently. And then since that was kind of a long, dense thing, I thought I'd just share a picture of Hawaii here just for a second so we can all kind of relax. All right, so let's recap. AI is the broadest term used when referring to machine learning and other types of AI, deep learning and Gen AI. We have a model, we train it, and then we use that model to infer. Basis for AI decision-making process for foundation models. That's all that works, multimodal models, and large language models. Lastly, we talk about diffusion models, breaking images into noise and then reconstructing new images, and then all the things that we went through before. So that concludes my very quick and high-level introduction to AI. I'll be happy to answer any questions you guys may have.
Thank you, Jay. Thank you so much for that presentation. One question that we have is, what are some good AI resources available on campus?
Good question. As I mentioned before, we have some AI. Let me see if I can pull up I'm going to stop sharing here for a second. If you go to the campus website and just Google AI stuff, we have a lot, and somebody else could probably speak better to that, I think, maybe.
Oh, we've Tino left a link in the chat about some AI
Oh, perfect. Yeah,
information.
there it is. Yeah, there's a link there. Thank you, Tino. And yeah, I do understand that this is a very dense and fast presentation. AI is just, it's so cutting edge, and so it's impossible to keep this thing updated. So I mean, it's probably out of date already. So, but it's a fun technology, and I think it's got uses as long as we can recognize some of the shortcomings and challenges that we have to deal with it.
Yep. Are there any questions people would like to add to the chat? We have about a minute. All right, I think we are good. Thank you so much. Oh, you said Skynet is real already?
No, not quite yet. So
Not quite.
we're still on the very narrow end of AI where we can kind of train it and kind of sort of get the outputs that we want. But in 10 years, 20 years, who knows? We might have US robotics and little iRobots running around everywhere.
Yeah. Skynet is only in alpha testing,
That's right. That's right.
according to Andrew.
All right. Well, thank you
so
everybody for attending. I appreciate it.
Yeah. Thank you so much, everyone. The recording should be available pretty soon after this if you want to come back and listen to it again and fully absorb the information and share it with your friends. But thank you for your attendance today, and we will see you in other sessions later today. Thanks, everyone.